All right, I wanted to go over just real quick how to make wave diagrams. Really just the four general types that you can have, and then how to use our half-angle equation. I feel like that would be something important to know. It'll be on your test. The example we used in class was like just something in the water bobbing up and down. If you have something that's not moving, then the ripples that leave the, let's say it's a boat, okay, they're going to be relatively equal, okay, going out, and we'll say the object's here just in the center. All right, so that's when the velocity of the object is 0. Then eventually we're going to get to a point where the object's going to be moving. Let's say it's moving to the right. In this case, though, the velocity of the object is going to be less than the velocity of the wave it's creating. We'll just draw the circles, and in this case the circles are going to start to, or the waves are going to start to be congested on one side. You can see here they're just a little bit closer on this side than on this side. They're a little bit more stretched. And then we'll eventually get to the point where the velocity of the object's equal to the velocity of the wave being created. And when that happens, you get something like this. Okay? Now, when we get to the point where the object, in this case the boat, is exceeding the speed of the waves it's creating, meaning it's going faster, so it's already passed over the spot of the water before the waves really formed, then we get a waveform that looks like this. Okay. And we usually draw a little something like that. And so that's where the velocity of the object is greater than the velocity of the water, or the velocity of the wave. This is, if you ever watch slow-mo videos or the slow-mo guys, they have several videos of shooting bullets into water, and you can actually kind of see these bubbles forming like this in the water, and that's a pretty good representation of what it looks like. Now, using this, I'm going to draw this again, just a little bit bigger, so you guys can see better the example. Let's get rid of that little part there. Okay. What we've got here is that if we start here at the center of the most recent bubble and draw a right angle out from my wall here of this V. Okay, this V represents the edge of where the wave has gotten to. This length right here would represent just the speed that the object, the speed that the wave is going. But technically, the object's out here. So we could draw another line, okay, to the front there. And I know this doesn't make sense, but they tend to use Vs, so not for the speed of sound or anything like that, just velocity of our object is Vs. And then we have this angle right here. Okay, so we can get the equation, the sine of that angle is going to be equal to opposite over hypotenuse, V over Vs. And we call this our half-angle equation. Now, a lot of people get this section mixed up. There's another equation that we use, okay? It's called our Mach number equation. The Mach number equation is Vs over V. And sometimes people would get those two mixed up. However, the best way to know if you mixed it up or not is if you're solving for the angle with this guy and you had these two swapped, your calculator will read error. So that's honestly a pretty good way to know. Notice they call it the half angle just because I'm only reading half the overall angle that exists. So this could be a drawing of, say, a sonic boom, okay, a shock wave. It's not a bow wave or bow wave. Those are two-dimensional. This is a three-dimensional representation. And if we know what the object speed is and how fast the wave can go through the water, then we can calculate the size of this wave, the size of the shock wave, by judging the half angle. The Mach number is usually just a representation of how fast an object is going in respect to sound. A classic example of this would just be, so my Mach number is going to be equal to Vs. Once again, that's the speed of the object. Let's say it is going 340 meters per second, and the speed of sound through air is 340 meters per second. So that just equals 1, a Mach number of 1. So if I'm going Mach 1, then I'm going at the speed of sound. Okay. If I was going 680 meters per second, then that would be Mach 2, and so forth. Nice thing about this equation up here is I can use Mach numbers, or I can use just standard velocities to get my answer. So for example, let's say I wanted to know what was the angle, right down here, what's the angle for an aircraft going at twice the speed of sound? Okay, well, if I rearrange my equation, I get this, right, for my angle. So that's my general equation I'm going to use. Now I can plug in the numbers one of two ways. Okay, I can put in my angle is equal to inverse sine of Mach 1 for the speed of sound, which is v, divided by Mach 2, because I'm going to the speed of sound. And I would get my answer. Or I could write it as the inverse sine of 340 meters per second divided by 680 meters per second. And I get the same number. These cancel my units. 340 divided by 680 is 1/2, just like this, and I'm going to get the same value. So I can use this equation to solve from using not Mach numbers or just using standard velocities. Either way works. They're just a ratio. So anyways, if you have any questions, please feel free to come in and ask me. On the homework, under these kind of problems, I think all of them, I put it both ways. I did it Mach number way and I did it velocity wave. People generally aren't sure which one to start with. Whatever the problem itself gives you, that's just what I use. So if the problem gave me Mach numbers to start with, then I use Mach numbers. If the problem gave me velocities, then I use velocities. That's kind of my general rule for it. So if you have any questions, come in and ask.